It was in July of 2023. Indigo, India's largest airline, quietly pulled 6 Airbus IAR jets from service. There was no public announcement and no press release either, just 6 planes that stopped appearing on departure boards. But within just 2 weeks, Go First, another Indian low-cost carrier, filed for bankruptcy. Its CEO said the reason was straightforward. Pratt and Whitney had failed to deliver serviceable replacement engines, leaving Go First unable to fly a third of its fleet. By the time September arrived, the numbers had become impossible to ignore. Approximately 600 to 900 aircraft powered by Pratt and Whitney's PW1100G engine were sitting on the ground across 60 airlines in 45 countries. The total figure kept climbing. Airlines were canceling thousands of flights per week. The crisis was, by any measure, one of the worst supply chain collapses in commercial aviation history, and most passengers had no idea it was happening. This is not primarily a story about one bad batch of engines. The PW1100G powers the Airbus ACI family, the best-selling commercial aircraft on Earth. More than 1,000 of those engines were installed on planes, actively flying passengers when the defect was discovered. What Pratt and Whitney found in the summer of 2023 was that a manufacturing process used between 2015 and 2021 had introduced microscopic metal contamination into the high-pressure turbine discs at the core of the engine. The contamination was not visible to the eye. It was not detectable during normal inspection cycles, and it had the potential to cause a disc to crack under the thermal stress of flight. That kind of failure in an engine spinning at 24,000 revolutions per minute does not produce a manageable in-flight emergency. It produces catastrophic structural disintegration. But here is what makes no sense. Pratt and Whitney knew something was wrong long before July 2023. The company had been monitoring anomalies in its inspection data since 2021. The FAA had been in communication with Pratt and Whitney about its accelerated inspection requirements for more than a year before the full scope of the problem became public. And yet, the formal airworthiness directive that triggered the mass groundings did not arrive until September 2023, more than 2 years after the earliest internal flags. In that window, hundreds of affected engines continued flying passengers around the world. To understand how this happened, you first need to understand what powder metal is and exactly why it matters. Modern jet engines operate in environments of extraordinary violence, temperatures that exceed the melting point of the metals they're made from, pressures that would flatten a car, rotational forces that generate thousands of times the load of gravity. The components that survive those conditions are not made from standard forgings. They're made from powder metal, an alloy produced by atomizing molten metal into fine particles, pressing those particles under extreme heat and pressure, and creating a disc that is stronger, denser, and more uniform than anything achievable through conventional casting. The PW1100G's high-pressure turbine discs were made this way, and the contamination problem was introduced during the powder metal processing itself, specifically during a step where rare earth elements are used to refine the alloy's microstructure. If that process is imperfect, the finished disc contains invisible pockets of compromised material that can initiate cracks under stress. Pratt and Whitney's position when the crisis became public was that no aircraft had ever experienced an in-flight disc failure as a result of the defect. That statement was technically accurate. It was also somewhat beside the point. The airworthiness directive, requiring accelerated inspections, was issued precisely because the company could not guarantee that no such failure would occur. Regulators don't wait for planes to fall out of the sky before mandating fleet-wide engine inspections. The defect had to be found on the ground at the cost of removing engines from service and inspecting them at intervals far shorter than their normal maintenance schedule. That inspection burden is where the crisis turned from a safety problem into an operational catastrophe. A normal PW1100G overhaul cycle runs approximately 20,000 to 25,000 flight hours. The accelerated inspection directive required some engines to be pulled from service after as few as 1,000 hours, a 20-fold increase in inspection frequency. Each inspection requires removing the engine from the wing, shipping it to a maintenance facility, disassembling it to the core, inspecting the turbine discs with specialist equipment, and reassembling it before it can fly again. Pratt & Whitney's network of maintenance, repair, and overhaul facilities was not built to handle that volume. In the second half of 2023, the MRO queue backed up to the point where engines were waiting 6 months or longer for the required shop visits. Airlines couldn't get their planes back in the air, and the backlog was growing faster than Pratt and Whitney's capacity to clear it. The airlines bearing the worst impact were not the legacy carriers with diverse fleets. They were the budget operators who had built their entire business model around the AI Archeneo family. Indigo had over Senbai AI Archeneo aircraft on order. Go First had a total of 120. Wizz Air, the Hungarian low-cost carrier, operated more than 170. When a quarter of your fleet is grounded by an engine crisis, you cannot simply substitute other aircraft. The losses are immediate and structural. Go First's bankruptcy was directly attributed to the grounding. The airline said publicly that Pratt & Whitney's inability to supply serviceable engines had made continued operation impossible. Against all logic, Pratt & Whitney's response to the crisis was, by the company's own admission, slower than it should have been. And in October of 2023, parent company RTX, formerly Raytheon Technologies, took a $3 billion charge against earnings, specifically related to the PW1100G crisis. That figure covered accelerated inspections, compensation payments to affected airlines, and the cost of expediting MRO capacity expansion. Analysts estimated the total cost, including lost future contracts and reputational damage, could reach $6 to $8 billion. RTX's stock dropped more than 15% in a single day. When the full scope of the crisis was disclosed, the company promised to add MRO capacity. It promised faster turnaround times. The queue continued to grow. What made the situation genuinely alarming, beyond the immediate operational chaos, was simply the trajectory itself. In mid-2023, Pratt & Whitney estimated that approximately 200 engines needed immediate inspection. By late 2023, revised analysis had pushed that number to 600 to 700. By early 2024, some estimates suggested the total population of affected engines, those requiring accelerated inspections during their next shop visit, could reach 1,200 or more. Each revised estimate was worse than the last. The crisis was not resolving. It was expanding as engineers developed a more complete understanding of how widely the contamination had been distributed across production batches. The airline-by-airline damage was severe and asymmetric. Indigo, which had bet its entire fleet expansion strategy on the AI Archeneo family, found itself managing a rotating pool of grounded aircraft that at peak exceeded 60 jets simultaneously, roughly 20% of its operational fleet. It negotiated partial compensation with Pratt & Whitney, leased older Sony Archeneo aircraft at premium rates to cover capacity gaps, and absorb delays on its own order book as the MRO backlog displaced aircraft deliveries. Go First was much less fortunate, with a smaller balance sheet and no alternative fleet to draw on. The airline had no buffer for a prolonged grounding. When it filed for insolvency in May 2023, it cited Pratt & Whitney's failure to supply serviceable engines as the direct cause of approximately $20 million per month in losses. In the period immediately before filing, Wizz Air, the Central and Eastern European low-cost carrier with over Archeneo aircraft, disclosed that the groundings had reduced its available capacity by approximately 10% at peak. It accelerated wet lease agreements with other carriers to borrow aircraft during peak summer travel periods, adding costs that its ultra-low-cost model was not designed to absorb. In investor presentations, Wizz Air management described the engine situation as the single largest external factor affecting its financial performance through 2024, a statement that put it in stark company with carriers across 4 continents, all making nearly identical disclosures. What complicated the situation further was the difference between engines that needed immediate removal and engines that needed inspection at their next scheduled shop visit. Pratt & Whitney's initial communications to airlines and regulators focused on the most critical population, engines with the highest risk profile based on flight cycles, accumulated and specific production batch. But as the analysis deepened, it became clear that a larger secondary population of engines would also require accelerated inspection before their normal overhaul interval. Airlines that had received initial assurances about their specific fleets then received revised assessments requiring earlier shop visits than planned. Trust between Pratt and Whitney and its airline customers, already strained by the initial crisis response, deteriorated further with each revision. The broader implication is structural. The Archaneo family was designed around the assumption that its engines would be reliable enough to support the intense utilization rates that make narrow-body economics work. An Archaneo on a budget carrier might fly 6 to 8 sectors per Dalton Y. It might accumulate 4,000 flight hours per year. That utilization model only functions if the engines stay on the wing long enough to justify the asset cost. When inspection intervals are compressed to a fraction of their design parameters and the underlying economics collapse, and when the manufacturer's MRO network cannot keep pace with the inspection demand, the economic damage multiplies across every operator in the global fleet. The reputational cost to Pratt and Whitney's parent company, RTX, is harder to quantify, but unmistakably real. RTX had positioned the PW1100G as the engine that would define its relationship with Airbus and its airline customers for the next 3 decades. The Archaneo family is expected to remain in production through at least the mid-Century, with thousands of aircraft yet to be delivered. Every airline that suffered significant grounding losses in 2023 and 2024 is now evaluating its future engine selection decisions, and Pratt & Whitney's primary competitor, CFM International, with its LEAP-1A engine, is the alternative that airlines are increasingly considering when they have the contractual flexibility to choose. The crisis did not just cost RTX the $3 billion it took as a charge. It put every future engine selection on the Archaneo family into play as a competitive decision rather than a default continuation. The PW1100G crisis is not over. As of the information available through mid-2025, a meaningful proportion of the affected engines had been inspected and cleared, but the queue had not been fully eliminated. Airlines were still managing capacity with grounded aircraft. The full clearance of all affected engines was not projected to be complete until 2026 at the earliest, and that is exactly the point. Aviation's safety record is built on the assumption that when a systemic defect is discovered, the system can respond fast enough to contain the risk before it becomes a catastrophe. The PW1100G crisis tested that assumption against a defect affecting more than 1,000 engines simultaneously, with a manufacturing window spanning 6 years. On the world's most popular commercial aircraft, the system is still responding. The planes are